So today's lesson is supposed to be about trigonometry. And so I'm just going to spell that out for you because it's so trigonometry. Trigonometry. Oftentimes we just abbreviate this as trig. Now there are two common types of trigonometry called right triangle trigonometry, and the other type is unit circle trigonometry. Now, as it happens, these two, once you learn a little bit more about them, are essentially the same in terms of what you can do with them and how. However, they are a little bit different in terms of how you get introduced to things. So, this bit right now is just going to be introducing you a little bit to what the basic ideas behind them are, and then I'm going to make separate recordings for what each of them actually end up dealing with. So, right triangle trigonometry, as the name suggests, has to do with right triangles. So, in case you don't remember, a right triangle is, one second. A right triangle is a triangle like, say, this, where you have a right angle. And so, how do we denote a right angle? We note it like this. So that means that this angle right here is a 90-degree angle. And so, right triangle trigonometry has to do with essentially the ratios of the sides of a right triangle. So, oftentimes we'll have an angle like this, which we call theta, which is not this right angle, and we'll care about what the ratio of, say, this side to this side, or to this side, this side to this side, or this side to this side, what those ratios are. Unit circle trigonometry has to deal with, as the name suggests, a circle. And so let's go ahead and put a circle here. You just have a circle, right? But you might be wondering, well, what does the unit part of unit circle mean? Well, the unit part just tells us that the radius of the circle that we care about is 1. And the reason why we use a unit circle and not just any old circle with radius 3, 5, whatever, is because when we use a circle with radius 1, there are a few things that we can focus on more in depth, and in some cases, the math and actual calculations are a lot simpler if we don't actually, because we're using the circle as a tool to talk about something else. Now, a lot of people might be a little bit confused, because oftentimes when we talk about right triangle trigonometry, we use what we call degrees. So you're probably already a little bit familiar with that. So what you might remember is that in a triangle, any triangle, the sum of the angles is 180 degrees. And so in a right triangle, you have a 90-degree angle all the time. And so 180 minus 90 degrees means that the other two angles have to be equal to 90 degrees. The sum of their angles has to be equal to 90 degrees. So this angle plus this angle have to add up to 90 degrees. In unit circle trigonometry, we use something different called radians. And so this is how you spell it. Radians. So R-A-D-I-A-N-S. So to illustrate that, I'm going to go over and look at this semicircle of radius 1. So it's a radius 1 circle because the distance from the center, at this point the origin, 0, 0, to any of the outlying points is 1. And I call it a semicircle because it's half of a circle, semi meaning half. So when you have degrees, it's very convenient to talk about, let's say, angles of a triangle. When you have radians, what we care about is often more so rotations. And so let's go ahead and say we start with this point right here. And we want to move it over to, let's say, this point right here. To do that, we would be moving it on this path halfway around the semicircle, right? It would be halfway around the semicircle. And so, with radians, if it's halfway, then you would say you're turning it by pi over 2 radians. If it's simpler to think of, then you can think of it as pi times 1/2 radians. So the pi over 2 just means that you're turning you're turning pi times 1 over 2 radians, and 1 over 2 in this case just tells us we're going around halfway through the circle or semicircle. So if pi over 2 is halfway through the semicircle, we can think of going the whole way through the semicircle, rotating this point from here to, let's say, here, as, well, what is twice pi over 2? That's just pi, right? And so going from here to all the way over here, that would be pi times 1, or just pi radians. So this is very useful when we're talking about moving or rotating, because we can essentially, instead of having to think, okay, how many rotations is 180 degrees, anything like that, we can just go, oh, okay, pi radians is just one full rotation, or one rotation around the semicircle. Pi over 2 is just half of a semicircle. It allows us to think very simply about things like that. Now, so radians are very good if you want to talk about rotations, especially around semicircle. So what happens if we bring in the whole circle? Well, we consider ourselves to still be starting around this point, and to be going in this direction around the circle. So, this is pi over 2 radians. This is pi radians. And so what is this? Well, you would be going in this direction one time by pi over 2. Then to get to another point here, you would go another pi over 2. And it looks like it's about the same distance, about a quarter of the full circle each time. And so to go another quarter of the circle, you would just go another pi over 2 radians. So this would be, you would say, 3 pi over 2. So we could think of this as 3 quarter circles, 3 quarter circle rotations. And finally, if we want to go all the way back here, we would be back at, well, it would be 4 pi over 2, which adds up to just 2 pi. Or we could think of it as going around the circle one time by pi radians, so one semicircle, and then going another semicircle to 2 pi radians. Now, interestingly enough, we could also just go ahead and go another pi radian. And so we have 3 pi radians. And so one way to think of this is that 2 pi, so 0 radians is this point, 2 pi radians is the same point, and so 2 pi radians is kind of equal to 0 radians. And 3 pi radians is also kind of equal to pi radians, etc. Now, let's go ahead and think back to degrees. So we have these numbers in radians right now, but what happens if we go to, let's say, degrees? Well, so starting at this point, you have 0 degrees, right? But so if we go to this point, let's look at this angle right here. This angle right here is a 180, or sorry, this angle right here is half of a 180 degree angle, and is thus 90 degrees. And so the same point is 90 degrees. This angle right here is 180 degrees, and so it would be 180 degrees is equal to pi radians. 9 degrees is equal to pi over 2 radians. By the same logic, we can say that 3 pi over 2 radians is equal to 270 degrees, and that 2 pi radians is equal to 360 degrees. And so when you go around by 2 pi radians, when you spin by 2 pi radians, you're back where you started, just as when you rotate yourself by 306 degrees, you go back where you started. And just like with radians, if you use degrees, you can also keep going. So you can, for example, go to 450 degrees if you wanted. And so that would just put you at the same place where you would be if you were, if you turned 90 degrees. Now, so let's go back here. Now, let's go ahead and say that we want to convert an angle in degrees to an angle in radians, because there seems to be some relationship we can think of, right? So, for convenience, so the thing I want to highlight is, let's go ahead and use this as a reference. So we're saying that 180, and for convenience, let's go ahead and use DEG for degrees. Is 180 degrees is equal to pi, and let's use RAD, supposed to be an R, for radians. So 180 degrees is equal to pi radians. And so if you have 180 degrees is equal to pi radians, then you could just do 180. Or actually, sorry, you can divide both sides by 180. And that way you get 1 degree is equal to pi over 180 radians. And so if you want to, say, convert, let's say 300 degrees to radians, what you would just say is, well, 1 degree is equal to pi divided by 180 radians. And so 300 degrees would be equal to 300 times pi over 180 radians. And so if we just think about this for a second, 300 over 180 is equal to 30 over 18, and that is equal to 15 over 9. And 15 over 9 is equal to 5 over 3, and therefore 300 degrees is equal to 5 pi over 3 radians. Now, that's for converting from degrees to radians. And for radians, the process is essentially the same. So, starting with this old equation here, what if instead of dividing by 180, we instead divided by, what if instead of dividing by 180, we instead divide by pi? If we do that, then what do we get? Well, we get 180 over pi degrees is equal to 1 radian. And therefore, let's go ahead and say we want to do 7 pi over 4. So let's go ahead and say we want to do 7 pi over 4 radians. Then 7 pi over 4 radians would be equal to 7 pi over 4 times 180 over pi. And so in this case, the 2 pi's would cancel out. And then we get 7 times 180 divided by 4. 180 divided by 4 is, what is that? That's 45. And so this is equal to 7 times 45 degrees. So 7 times 45 is going to be 210 plus 35, and which is thus going to be sorry, it's going to be 280 plus 45, and so it's going to be 325 degrees. And so you can see that if we use 180 over pi degrees is equal to 1 radian, or pi over 180 radians is equal to 1 degree, we can essentially convert between radians and degrees super easily. Now, one thing to remember is that when we're doing these conversions, you can memorize the formula 180 over pi, but oftentimes it's easier if you just do 180 degrees is equal to pi radians, and then you just think, okay, how do we convert? How do we want to do radians to degrees? If we want to do radians to degrees, then we could divide pi radians by pi, and so we just get 1 radian on this side. So we get 180 over pi equals 1 radian, and then you could just multiply by however many radians you care about. And the same thing with degrees. You want to get 1 on this side, and so you just do the division, and you get 1 degree is equal to pi over 180 radians. You can either remember the formulas, or you can just remember this and think through what formula you would use on the spot. Either one is fine. And so for unit circle trigonometry, we will mainly be using radians. So keep that in mind.